Okay, great. Thank you all for joining today. We are going to be doing a special live stream called Depain Blockchain with a focus on Ethereum today. I'm Jessica Levesque, C4's Executive Director, and we have C4's CEP Committee with us today. So we've got Josh, we've got Kent, we've got Dustin, and Sonal. And we're going to get right into it. So the purpose of this is to just get into what some of the terms you may hear, define those briefly, and then we're going to get into kind of what a user flow might be when you just start understanding Ethereum and what it might look like to start to access the Ethereum network and what you might be doing on it. So let's start with some high-level terms just to make sure that we're all on the same page. And I think we should start by just saying, what is Ethereum? That seems like a good place to start. So who wants to start with it, just explaining what is Ethereum and what is a blockchain? Josh? I say who, but then I'm calling on you. You're welcome.
I think Kent would be best to go over this personally.
Okay, so yeah, let's start at the very high level. Occasionally, you will hear Ethereum referred to as like a world computer, and I think that's not a bad definition. So right off the bat, you think, okay, well, what does a computer do? Well, you can do all sorts of different stuff on a computer. It's not just one thing. So immediately, this is a bit of a departure and a contrast to what Bitcoin does, which is, Bitcoin is very good at transferring Bitcoin back and forth. That's what it does. It's very secure and decentralized. Ethereum has always been designed to do more than that, but maintain these these fundamental properties and expand on kind of what Bitcoin did with decentralization. What makes it a world computer? Maybe it sounds a little bit like okay, it's like the internet. What the hell? The internet's also like a world thing. But really, what makes it a world computer is kind of these properties that arise thanks to blockchain technology. These are some very important things. Censorship resistance. Anybody across the world, unless you happen to be like, say, in North Korea or maybe China, can access Ethereum and use it. It's permissionless, censorship resistance. Anybody can publish code. You don't have to ask permission from some government or corporation to publish code on Ethereum. This is really important. You don't need permission from anybody to do stuff on Ethereum. It's also immutable. And by the way, these properties are similar to Bitcoin in the sense that anything that happens on the blockchain, and you can get into the hows and whys this happens, but nobody can kind of turn around and say, well, I sent Josh an ETH yesterday, but I'm going to be a bit of a jerk and just sort of like take that ETH back, or we can be very certain that I sent Josh that ETH and that it's not going to be and that it's immutable. It's not going to be changed. So you also hear about smart contracts, and these live on Ethereum, and they enable this more broader functionality. That's kind of like super high level. We can get into it, and this informs things like decentralized applications, transactions that we can dig into. But that's at a high level, kind of what we're looking at with Ethereum.
Yeah, and I think something to point out is anytime we learn some type of new technology or pretty much any new subject, we're going to come across terms that we need to say in order to explain other terms that we'll then get back to. So there's sort of a cyclical piece to this where some of the words that Kent used to describe Ethereum, like blockchain, decentralized, immutable, smart contract, you might be thinking, okay, you're using words I don't know to explain a word I don't know, but stick with us because we kind of have to cycle around to do that. So you now have heard how these terms are applied in Ethereum. Let's break down these terms a little bit more to reframe a little bit of what Kent said. So we talked about a blockchain, and blockchains, you were saying, are immutable, which again means that, like you said, once you put something on it, it's there. That is now built into the data of that blockchain. So that's the immutable piece. Blockchain in general is a ledger, basically a database that keeps information on it that can't be changed. Now, what terms did I maybe say that we need to now go back to explain, or any others that Kent brought up? Anybody on this call hear any of the other words that you think we should circle back to?
Do we
No,
have a
it was perfect.
definition for immutable?
Yeah. Do I have a definition for immutable? Is that what you asked? Sure. It can't be changed. Is that a good, is that a good definition?
That was the definition, but it's since changed.
Oh, okay.
Hilarious immutable joke.
It was pretty good. But so basically we've got this new type of technology. It's not, I wouldn't call it quite new anymore, but it is still somewhat new. That is a way to record data in a way that can't be changed. And like Ken said, it's global compute. It's a world computer, which means anybody can access this information if you've got an internet connection and are in a place where you can do so. So anything that is sent on this can be seen by others. Like Ken said, if he sent ETH to Josh, he couldn't just be like, hey man, give that back to me. And ETH is the currency on the Ethereum network. And let's see, anything else that you think we should discuss before we move on? Maybe we want to explain what a smart contract is. Dustin, do you want to do that? Or Josh?
Sure, I'll hit this one up. So a smart contract is just like an app on your phone or computer or anything like that. The difference is that rather than it being, you know, just an app I have and then an app Kent has, an app Sonal has, we all have the same app installed on our phone, but the states of that app are a little bit different. You know, I might keep track of my high scores in a game and Kent might keep track of his high scores in a game. And, you know, they're different device to device. Or, you know, my photo album might have my photos in it where they certainly differ on the phones of others. The way a smart contract works in the Ethereum sense, and this is why Kent used the term world computer, is we all share the state of that one application. So, you know, imagine opening up a spreadsheet like Google Sheets and everyone just working in the exact same spreadsheet together. It sounds a little bit chaotic, but an app is really what enforces the rules on how we get to, or a smart contract is how we get to enforce the rules on that state to say, you know, I can update the balance I have on mine by creating a send transaction and moving my Ether over to Kent. Or in a more complex state, you know, I can interact with this exchange smart contract to convert one token I have on the Ethereum network to the other. The contract itself would hold that state and you know, be what we interact with, but ultimately it's similar to, you know, just a calculator saying 1 + 1, and every single computer on the Ethereum network calculating and going, yep, it's 2.
That was great. Do we want to say anything else about decentralized applications, also known as dApps?
Sure, I can jump into that. So I think Josh alluded to it earlier when he talked about having an exchange application. So when an application or a smart contract is deployed on Ethereum, it's generally considered to be a decentralized application. Now, how is this different from any other application? So if you think about most of the things that you work on the internet now, they are deployed on the cloud. So for example, you work on Google Sheets, you work on Gmail, those are cloud applications. But it's a cloud that belongs to someone. It's either deployed on AWS, Google Cloud, or many other cloud providers. What happens with dApps, or why they call it decentralized applications, is that these applications are not deployed on a centralized cloud solution that somebody owns, a company or anything like that. It's actually deployed on the Ethereum blockchain. What this enables us to do is that it inherits those properties that we talked about of censorship resistance and decentralization, where once an app is deployed on the Ethereum blockchain, you can't remove access to the app, you can't change the app unless the original deployers of the app want to do anything to it. So it is permissionless in the sense that it allows you to deploy an application that people can interact with, and you don't have to seek permission to do it. You don't have to worry about it being taken off the cloud. If you did it on Google Cloud or AWS, if you violated your terms of service, they could take your app off the cloud. if you deploy the dApp on Ethereum, no one can take that dApp away from you. People can tell other people not to use it anymore, but no one has the permission to censor the use of that application.
Yeah, so a lot of times you'll hear the word like censorship resistance, which is exactly what Dustin was just talking about. You'll hear that it's borderless, which is what we heard with the world computer. You'll hear immutable, which is about the blockchain. It's the data on the blockchain not changing once it's been added to the chain. So these terms and many others you're going to hear, and hopefully we'll walk you through them as we go. The last term I think we threw out that we haven't gotten into maybe a little bit was Ether. So Ether is the currency that is used on chain, and it's also called ETH because, you know, Ethereum, Ether, ETH, we like to throw in a lot of different terms, I guess. But if you hear someone saying I sent somebody ETH, it is the currency for Ethereum. And there's other units of account within Ether. We might get into it a little bit, but basically you just need to know that if someone says, hey, can you send me some ETH or can I send you an ETH? What does that mean? What does that look like? And I think, Dustin, you wanted to start getting into this a little bit with what is kind of the basics? What are the first things that you would do when you're starting to participate in the Ethereum network in a meaningful way?
Sure. One of the first things that you would do when you want to start interacting with the Ethereum blockchain would be you want to get a wallet. So what does getting a wallet mean? If Kent, you could take over what getting over a wallet means verbally, and I will switch over to the screen share and I'll share images that go through what we're talking about when we talk about creating a wallet, for example.
Okay, a wallet. So this kind of relates to the idea of having a unique Ethereum account, which is like your special little address where everything lives that you have control over. So wallets can take different shapes and forms. Kind of the simplest way to use a wallet that I think we'll look at shortly here is like what's called a software wallet, where it's connected to the basically a web browser. It's a very easy and free thing to use. That's crucial. What makes it unique in the way that you get your kind of your own special Ethereum account that only you have access to is via something called a seed phrase, like a list of words that can be used to generate this this unique account. If you want to get into the how this works, it's something called public key cryptography that's been around for a while. It's one of the fundamental things that drives that was really behind the advent of Bitcoin as a secure payment network, and then Ethereum also adopted. Wallets can also take the form of hardware wallets, which are much more secure. That's probably a whole other episode. And there's a few other ways to go about it. You can even have them on your phone. But the key thing to understand here is this is also your way, well, as the name sort of suggests, a wallet, holds funds, and it certainly does. In reality, what it's doing is it gives you the permission to spend funds from these accounts, and people can send you that address. But crucially, and this is kind of one area where maybe the wallet term could be expanded, but it's also a way to interact with the decentralized applications we were talking about. So that's kind of how you're, interacting in a account sense with dApps. It's sort of your portal into this world. So it looks like we have MetaMask up here on the screen.
Just jumping in for a quick second to kind of compare this to how you normally interact with apps. If I create, let's say, I want to interact with either Google Suites or, Hotmail or some sort of service. Generally, what I do first is create my account on that service. So maybe I give them my email address, create a password, and that service stores those records for me. Now, every time I interact with that service, it might say, hey, what's your password? Oh, okay, great. I remember you now. And now I keep, interacting with that service. Now, if I had my account on Gmail, and then I go over to Hotmail and I try and log in with the exact same credentials, I've never had that relationship with Hotmail or Yahoo. So they're going to go, I don't know what that username and password is, because each of these services store those things themselves, store themselves locally within their business. So it doesn't recognize me. When we're dealing with a blockchain network like Ethereum, there's no service to register to. There's no one to say, hey, I want an account. Instead, what you're doing is creating that secret on your own. And that secret is how you authorize to all these different systems. You're never asking permission, hey, can I access this network? Instead, what you're saying is, hey, I have this secret personally. I'm going to hold this. And this is my identity for the network. And I can actually take that same identity and use it in different software and different hardware wallets, move it around, because ultimately, no matter what, it's just about me proving I am this person. So it's a different paradigm where these centralized systems, we have to register with them, and they keep information on us that allows us to kind of validate who we are. Instead, we keep the information in a blockchain network, and we're able to use that to validate who we are. So it's very sensitive, because if anyone else has that secret information, they can then validate that they're you as well. So you want to make sure to keep that safe. But I just wanted to compare those two different paradigms and make sure that that was kind of more clear.
That was helpful. I think that was great. Anything else about what Josh just said or what Dustin was saying that we wanted to add on to? No?
If not, then
Okay.
back to backing up.
Okay, so let's get back into talking a little bit more about wallets. So Dustin was just showing MetaMask, which is one type of software application, one type of software wallet that you can use your secret phrase in order to gain access to your accounts or addresses, as Kent was saying. But there are different types of wallets. And so I think basically a wallet is a way that you can gain access to what you have on a blockchain like Ethereum and use it in order to make transactions and to do other really cool things. But let's start with a couple of different, some examples of what types of wallets there are. So when we just say wallet, that is kind of an umbrella term. And then underneath it, there are different types. So there's externally owned wallets, and there are smart contract wallets. And I want to keep this pretty high level, but maybe we can just talk about what kind of wallets we would use if we're just accessing the Ethereum network for the first time. So for example, Dustin, if you were to send Sonal some ETH, what wallet would you likely use? What would that look like? Did you want to show any more of that screen share, or did you want to maybe just walk us through what that might look like?
I can't normally talk and do the screen share at the same time. So what I'll do is I'll talk through an example, and then while others are talking, I will find an example that illustrates stuff as well. So I think that when you use wallets, there are often different paradigms where you'd use a wallet. There might be times that you prefer to use wallets for high value transactions at a desktop because maybe you need to be in a more focused space. You need to compare addresses and stuff like that. You prefer to do stuff on a big screen, maybe for high value transaction. You don't want to be doing it on a phone where you can't really see what you're doing. So I think that for most people, they have different contexts under which they use wallets. Where it's a high value transaction, they might pivot to a desktop. They might use a more secure wallet. And I think we'll go more in depth into other kinds of wallets that are available that provide better kinds of security. But you would maybe do it using a browser extension. So if you're familiar, you use browsers like Firefox or Chrome, and then those are like very vanilla browsers. They let you interact with the internet, but sometimes you install extensions that add features that your browser doesn't have as a default. So a lot of wallets started out as browser extensions, which is they add software into your browser inside its extension space, and it starts executing commands because your browser generally isn't able to interact with blockchain networks on their own. You normally need to install a wallet, and you generally need to install a wallet for specific kinds of blockchains. So for example, there are different blockchains. We were talking primarily about Ethereum, but you would install an Ethereum or Ethereum compatible wallet to use Ethereum networks, you would use a Cosmos wallet for Cosmos networks and all different kinds of networks. So in general, you could use a browser extension wallet, or you could install a software application wallet into your OS itself, which could be a Windows computer or a Mac computer. You could use it on your mobile phone. And I think that there are different wallets that cater to each of those. Some of them provide interesting features. For example, on your mobile phone, it would only allow you to sign transactions if you, let's say, give them your thumbprint or your face scan. So these are additional security properties that they can add on top of your wallet.
That was super helpful, Dustin. Did you want to you're going to screen share something in a minute? We can walk that through, but first maybe we could talk a little bit more about the basics of a transaction, and then we can get into some of the specifics with what you're screen sharing. But so Sonal, do you want to talk about just the basics of a transaction, either from the sender or the receiver, but just what is a transaction?
Yeah, sounds good. So a blockchain transaction is a transfer of value or data. I think that's important because in a lot of cases, it sounds like we're talking about monetary and finance use case, like only sending and receiving money. But as Kent explained earlier, Ethereum itself has vast use cases just beyond exchanging currencies. So in a lot of cases, we're also talking about transferring data. But in a transaction, you're transferring this data from one account to another on the blockchain network. So it involves updating the distributed ledger, so the blockchain, to reflect the transfer. You're adding a new block. So from a sender point of view, there's an address from where the transaction is initiated from, and it's controlled by the sender's private key. And then you use your recipient's address to identify where you're sending this new transaction to. And that can be another user's address, a smart contract, or a dApp. And then I know we'll get into some of this here, but other terms are involved that we started to touch on earlier, like Ether, which is used in this case as a gas fee. So you're paying for the computational resources used to update the blockchain. So all these terms, as Jessica mentioned, they're connected and related throughout all these use cases and processes throughout. But that's the basics of a transaction.
That was awesome. I hope some of the terms that we're using, you can kind of circle back to what you heard at the beginning and it'll all connect together. So right now, Dustin is showing sorry, I'm trying to zoom in here. He's showing a potential transaction on the Ethereum blockchain. You can see it says chain up at the top, which just means which chain. So there's a bunch of different networks I'm not explaining this well. There are a bunch of different side chains that can be used when you're using Ethereum, the larger network. Does anyone want to explain that better? Was that confusing? I saw you smile, Josh.
There's a lot of networks that are very similar to Ethereum, either based on Ethereum and made with slight changes and run kind of in unison with Ethereum, or actually run on a layer built on top of Ethereum. But ultimately, they're all pretty compatible with each other. So a lot of Ethereum wallets will support all of these other networks as well. And it might be common that you have to interact with a certain app on a different network, and it'll kind of be mostly seamless. We can go down a really big rabbit hole here, and I don't think that's going to be appropriate for this specific talk, but just know that you're likely wanting to interact with that main Ethereum network. But sometimes, especially if something requires lesser fees, or just the thing you're interacting with happens to be on a different one, it'll generally tell you what you need to do. So not really something that can go too wrong a lot of the time.
Just one related heads up as it relates to that. And you'll encounter this if you're just on Coinbase and you don't really have your own wallet set up outside of, say, an exchange like Coinbase. But when you're sending certain assets from a chain to chain, like maybe you have USDC, which is a stable coin. Maybe you're going to send that to somebody else on Ethereum, it's important to double check that whatever network you're sending to and from, matches the network that the asset is on. Some of these assets can exist on multiple chains and do exist on multiple chains. So you just, you're going to come across this chain thing. You're just going to want to be aware that, as Josh said, the nature of this technology means that a lot of these wallets can, really work with one another. But you have to be mindful that you're sending on the same network. It's nothing to be scared of, just something you want to keep in mind, and even like do little test transactions.
Yes.
But yeah, like it really is a rabbit hole that instead we'll look at Rabby and not the rabbit hole right now.
Yeah, definitely a great suggestion. It was just a quick little quip there. Sending test transactions. Anytime you need to send a significant amount of money, whatever significant is to you, send a smaller amount first. Try it out. Make sure that the recipient gets what they need. Make sure the results do what you expect. There is something really interesting going on this screen as well, which I think can be a little bit confusing at first too. I'm looking at this and we're talking about moving ETH, but I also see dollar values. I see, $304, $3,000 of the current price of ETH. I thought I was moving ETH. I'm not moving dollars. A lot of these software will go out and try and get you the value of what you're currently sending in a more familiar price to you. So, if you're in Canada, you can have this listing Canadian values for you. If you're anywhere in the world, you can likely set your own currency in these applications. That way you have a context as to what you're actually sending. Ultimately, you're not sending dollars. I'm not sending Canadian dollars. I'm sending ETH in this case because I've got ETH selected. It's just showing me what the value is currently of an ETH, what the value is currently of my transaction, and helping give me that context. So just a quick little, these apps try and be helpful, but sometimes it can be a little confusing if you're not sure what you're looking at. Usually what it's doing is it's helping give you that context, but you're actually sending the ETH. In this case, we've got ETH set, so we know we're sending ETH. We're not sending that actual dollar.
Yeah, it's kind of like when you're looking at your own stocks and you're buying and selling them. Even though it's showing you an amount, it's an actual unit of something that you uniquely own.
Mm-hmm. So here we've made that selection, and now we're choosing to kind of review what we've done here. And we can see, where's the token, where are we sending it to? And we see a little bit of the beginning and end. It's always good to kind of compare those again before we finally hit send on this. Never hurts to do a review. We see the amount of token out. Token is kind of the generic term of what we're sending here. So in this case, ETH, it's the ETH token that's being sent. If it's a different token, then we'll see that token listed, but that's just the generic term. Again, and we're going to show roughly the dollar value in my local currency to help give me that context. And then we're going to get into gas. Does anyone want to talk about gas a little bit?
Oh God, no. Okay, so the thing about gas, and the reason that gas exists, is that there are commands that are used in the EVM for things like transfers or for smart contract platforms like this, where you start having to build in more complex things which aren't just simple transfers. So gas is the denomination under which you can reliably say that this contract consumes this amount of gas for a simple transfer, for a swap, whatever the case may be. They just need a consistent denomination for execution. But that then needs to be converted into Ethereum when you use it for the actual fee. So what happens is that gas is it's basically a unit for computation, and that is converted into Ethereum. That's why you see that the gas price is calculated whenever you do a transaction. And if you're doing a transaction when ETH price is fluctuating, you might notice that your gas cost can change like by the minute, because it's like surge pricing for Uber. when the Ethereum network is in demand and lots of people want to get their transactions in, then the gas price increases because there's competition for those limited slots to get transactions into the network.
I want to quickly jump in here to talk a little bit about tokens. So Sonal, we can see up on here the word token and it was mentioned. Sonal, do you want to explain what we mean by tokens?
Yeah. So digital tokens on Ethereum and other blockchains are where you can create and use assets that are recorded on the blockchain. So it's a super cool attribute. Part of the reasons why things like Ethereum open a world of possibilities for proving ownership and verifying data. So digital tokens can represent virtually anything from traditional assets to currencies, or ownership of art, like in the case of NFTs. But if you record the tokens and the ownership on a blockchain, you're creating an immutable and transparent record of that ownership that can't be altered or deleted. So in this case as well, when we were looking at the transaction before, ETH itself, the ownership of an Ethereum, is considered a token. And Dustin's showing a screen right now of some NFTs. These are all tokenized assets as well. And it can also prove and represent ownership for things like credentials, certifications, votes in an election. So it's very vast.
Yeah, it's like you said, there's so many possibilities related to what we can do on Ethereum, which makes it so exciting and also is partially why it's confusing when you first start learning about it. It doesn't just do one thing. It's not just one simple something that happens. It's many things that can happen in many different ways. Excuse me if I missed this, but did we talk about what a native asset is versus ERC20 token yet? No?
I do not believe we have.
Okay. Can somebody address what a native asset is? Kent, maybe you want to explain the difference between that and ERC20 token. We've said what a token is. But
Okay, so just to clarify, we're talking about ETH being the native asset versus the ERC20s?
yes.
Yes. So ETH or Ether is, and we kind of touched on this as we were getting into the general topic here, but Ether is the currency of Ethereum. You might be wondering, like, why does a network actually need its own currency? Couldn't you just have something representing, say, like a stable coin or something representing the dollar or a euro or a yen or whatever? The reason, it's a couple of reasons actually. One is that it helps with network security. It helps to compensate the people that are running machines and spending time and resources and electricity on supporting the network and risking their capital. That's called a consensus, a whole other rabbit hole. It also gets into, this idea of gas. So gas is, Ether is sort of related to gas in the sense that it actually helps to pay for transactions. So here's kind of a good analogy. Imagine you want to exchange one ERC20 or token, like Sonal was talking about, for another token. So imagine you're at the Ethereum vending machine and you're like, okay, Ethereum, I want to swap this cat token for maybe Doge down here and do some sort of swap, or maybe I want to swap this for an NFT. In order to use the vending machine, you actually have to pay kind of a fee to the vending machine to use it. It's sort of like almost like a toll or something. If Ether didn't exist and the ability to pay the network didn't exist, you would run into problems like spam attacks and DDoS attacks, distributed denial of service attacks, and all sorts of bad things. So there's a number of reasons why Ethereum needs to exist as a currency, and you see this with other blockchains as well. Of course, Bitcoin is the native currency of Bitcoin. The network, you have other networks, Solana, Cosmos, that have their own native currencies. ERC20s are enabled by ultimately these like a network or a ERC that enabled that functionality, whereas ETH, the currency, has always been built into the system. And this is why over time, you've seen, and we certainly don't get into like an investment type stuff here at C4, but like this is why over time you've seen generally the price of Ethereum go up, is just because demand for the asset has increased as more people are using the network, because you need Ethereum to run the network.
Yeah, and I recently heard an interesting analogy to ERCs, to gift cards, where ERC20s are like gift cards in a shopping mall where you can have them to all different stores, but in the end, you're still using Ethereum itself, and it works. It all goes back to the same application and network. So it's interchangeable, and it can be traded for others, but it's a different format.
Awesome. That was helpful. Okay, so what else do we want to get into? We've talked about what a transaction is. ERC20 showed you an example of what it looks like. Should we talk a little, I know we talked about gas a bit, but should we talk about GWEI? Did we explain what that, I see Josh's eyes. Do we want to explain how that works? You might hear GWEI. You don't need to be a mathematician to be able to know how to do this.
I think you do.
No, don't scare people off, because your wallet will do it for you. Dustin, do you want to show again where that is on it and how GWEI is used? And maybe Josh, you want to explain, what am I even saying? I'm saying the word GWEI and you might be looking at me like I am an alien from outer space throwing out random terms. So I'm going to put the spelling of it in the YouTube chat, but yeah, why don't we explain what it is? Josh?
It's a unit of currency in Ether. So similar to how dollars have cents, $1 has a couple cents in there. 1 Ether has a certain amount of GWEI. Anyone think that's incorrect or want to go deeper on that?
Yeah, I mean, and it relates back to the computational power needed to execute transactions. So really, as a user, you just need to know gas is charged. You have to pay gas to execute a transaction, just like if you're going somewhere, or if you have fees when you're exchanging between currencies between different countries, you have to pay fees. But in this case, there's an exact unit of measurement because at a deeper level, we're talking about computational costs.
So let's say you have 1 Ether and you want to send somebody else 1 Ether. And that's all you have. You can't do that transaction because you have to use some ETH in order to send ETH. Basically, it's a transaction fee. It's a gas fee. So you need to have some either set aside, or you'd use part of that to be able to send the amount of it. So, and that cost is what keeps the network going, keeps it safe with staking, which we're not going to go into all of that. I think we've got some other live streams that cover that. But from a user standpoint, when you're looking at what Dustin is screen sharing right now, you see on here gas fee. And on the previous slide as well, he showed that there's different, you can choose to use more gas or less in order to speed up or slow down the transaction. So if you want to make it as quick as possible for the send to happen, you could increase the payment that you are putting out there. Anyone want to explain gas limits?
I think a good place to jump to is, the process of broadcasting. You might see broadcast, you might see send, commit, transfer, all sorts of terms, but ultimately what's happening? You set up your transaction, where it's coming from, your wallet, where it's going to, your friend's wallet, that business's wallet, that smart contract, whichever one it is, the amount you're sending, the amount of gas you've defined. What happens when you click send? If there's no central authority, if there's no business that I then send the transaction to, that takes it and says, okay, yep, this is all valid, then what exactly is going on under the hood? Well, we use the term broadcast because ultimately we're not trying to send it to one specific individual or organization. I don't, if I'm sending this transaction, I don't actually take this transaction that I've built, sign it, and then send it to my friend. And then my friend looks at it and goes, yep, you've sent me the ether. We're not sending that piece of data to our friend. Instead, we're telling the entire Ethereum network about it. And what's going to happen is that piece of data that we call our transaction is going to go to all these different people running the Ethereum nodes around the world. And they're going to look at it and analyze it. And first they're going to make sure, is this correct? Did you have the authorization to send this money? Is your signature correct on it? 2, did you have that amount of money to send? Is on the ledger, do you currently have that amount? And then they're going to look at the gas. And they're going to compare it to the gas of all the other transactions that they currently have waiting. And if it's their turn to add a page to this ledger, they're going to look at the top transactions up to a certain point and say, okay, I can add all these in. If you haven't added enough gas to be at the top of their list, then they're going to say, you know what, I want to make more money, so I'm going to add these ones instead because the demand is there. So I add those, I add the page, I tell the network about that page. Everyone who is now on that page can see, oh, okay, great, I've been added. But if my transaction didn't fit the bill, well, now it just waits for the next person or the next miner to say, okay, or validator, whatever we're calling it now, to say, you know what, yeah, this transaction is currently in my list of ones that should be added. I'm going to add that transaction. I will get the gas fee, at least portion of it. And then, your transaction is now committed to chain. Once this happens, now it's very unlikely that transaction can be undone or altered in any sort of way.
Yeah, and it kind of reminds me of AWS, where you're, customizing your settings to have faster execution, higher priority to all the others using the network. So by setting your gas fee higher or lower, you're changing the priority in line on your transaction being processed.
Or your in your Amazon account when you're checking out your latest series of boxes that you'll be getting, you can choose when is this going to get delivered. If I pay a little bit extra, it's going to be delivered today. If I don't pay anything, it's going to be delivered here. If I want to get a little reimbursed, I can actually wait a week and it'll come then. So setting that priority, no different than ways you interact with your capital in normal daily life.
Yeah, and similar to that, your wallet is saying what you can do. So if you look under this with the basic, slow, average, fast, it tells you right there what the cost is, how quickly it will go. Can you wait an extra 2 minutes so that you can spend less? And so your wallet definitely does a lot of this math for you if you're using.
Or if you're seeing this estimate of $400 for a transaction, that generally means the network is highly congested. And you know what? If you don't need to send your friend this ETH today, maybe you send it another day when the fees are not completely insane. So you have the luxury of saying no, hopefully.
Well, and I would also point out that rather than people saying, oh, gas prices are too expensive, the transaction is going to cost too much, people who are working on Ethereum have done things to make it more scalable. So earlier we were talking about, you saw that little box that said chain and it said OP for optimism. And I don't want to get into this, but basically there are different advanced ways to send transactions that will reduce the cost of what you're doing. And so that is something that, when you're first sending a transaction, you're probably not going to be interested in. Like Josh said earlier, play around, small amounts, figuring it out. I think that playing with the technology is a good way to understand how it works. And then perhaps once you understand it, you've figured out what it looks like, then maybe you want to try to use Optimism or another chain. But it is possible to start slow, and then as you learn more, build on it and send more transactions in different ways. One of the words that we mentioned that I think we should talk about is broadcast. So I'm not sure who said this, but I think somebody brought up broadcasting a transaction. And this goes all the way back to what we started with in terms of the worldwide computer. So Kent, maybe we can toss it back to you and talking about a worldwide computer and why we're using the word broadcast. Broadcast obviously has broad insinuations. So how are we broadcasting transactions to this global computer?
Right.
Sorry,
So this
before we jump to Ken, very quickly, I just wanted to pick up on a point you made halfway through, which is the price of transactions. So I've switched over to Ethereum, the layer one, and you can see that the transaction now costs the equivalent of like $1.23. But as you were saying, if you switch to a layer two, if I made the same transaction, just to show you the impact of cost that it has when you transfer on a layer two instead of a layer one, the broadcast, the transaction fee is this amount, which is essentially, it's not free. It's just that you've only got 2 digits behind the decimal. So it doesn't go enough zeros to show you how cheap it is on a layer two. So if you do want to send transactions and you're complaining that the Ethereum L1 transaction fees are too high, there are many layer twos that have transaction fees that are fractions of a cent, much less than that.
So yeah, there are a lot of different options when you're sending, and we're not going to get into layers, but layers basically are what we were talking about, different chains, different options to play around with. But regardless of which way you're doing this, you are broadcasting this transaction onto this global network. So Kent, do you want to walk us through what that means?
Yeah, let's unpack that, because it's really sort of illustrative of the difference between a decentralized network, a blockchain like Ethereum, and something more centralized. So let's say instead of sending that ETH to Josh, I was going to send, say, $3,000 to Josh, and on Venmo. So with something like Venmo, it's like, okay, well, there's also clearly this request to send Josh money has to leave my computer and go to the platform that we're using. In the case of something centralized like Venmo, it's like a server request basically, and I send a message from my computer to Venmo's computer, and they process it and then say, "Hey, Josh, you just got $3,000 from Ken." Right on. It's a different paradigm with blockchains and with Ethereum. So when we talk about broadcasting, first and foremost, we're using the wallet that Dustin had up, or not that wallet specifically, but any wallet that interacts with Ethereum. We're doing what's called signing the message, basically proving that we have the ability and we own the key to unlock that amount of money. The system or the platform can detect via cryptography that this is actually the case, and then basically my request to send Josh an ETH is then broadcasted to the network. At this point, there's a real departure from doing something centralized like Venmo, because instead of just having a centralized, server or server farm or set of computers that handles it, the request or the transaction is then kind of like sent to the network, waiting for it to be included in a block. And this is why we call it a blockchain. Another way to put it basically is it's not like every time there's a transaction on Ethereum, it just gets instantly included. It has to be included into a block and then added by the sort of the consensus mechanism, or what we call validators in the Ethereum ecosystem. That itself is a vast rabbit hole we could really get into. But it's the important thing here is when it's been broadcasted, it's sort of in this intermediate stage where you're waiting for somebody, namely like a validator, to pick up, say, okay, I see the transaction. I see that you're, yes, you had the ETH to do whatever you want to do with it. I see that you, yes, you have the right to this account because you're using the right private key to unlock the funds basically and use it. And then it's waiting to get included into a block. Only once it's included in a block, which on the Ethereum mainnet happens something on the order of once every 12-ish seconds, I think. Assuming that happens, then it's actually part of the blockchain. And then you might want to wait a few more blocks for that wonderful immutability. But that's why we talk about broadcasting, because it's being broadcast to this network of validators who then subsequently, if everything is right, will include it. Now, one interesting thing, it happens less these days because we've had some upgrades in Ethereum. It used to be that if you didn't if you didn't include enough of a fee to be added in other words, if you didn't add on enough extra ETH to be included, you might not get included into a block. These days, it's for various reasons, it's easier. That doesn't happen very often. It's a lot more kind of in the background, but there could be a situation where maybe you broadcast a transaction and it doesn't get included for a long time, or maybe even ever. But in practical terms, using most wallet software today, really what it means is just like you send a transaction, you broadcast it, and then you want to wait for it to be confirmed. Wallets will provide usually confirmation that it's actually subsequently been confirmed in a block. You can also look at block explorers to do that.
Yeah, and one of the things that you've pointed out, and Dustin, you were showing blockchain.com, I think, briefly, but the idea of a block explorer, this is when we talk about this as a distributed ledger, this being Ethereum as a distributed ledger, and it's transparent. People can see what's happening on the ledger. We use a blockchain explorer to be able to check out what information has been added to a blockchain, to the Ethereum blockchain. So if I was to send Sonal 1 ETH, and then I wanted to double check that, I could look on a blockchain explorer to make sure it's been added. We can find out what address it was sent from, what address it was sent to, what the cost of the gas fee was, and different information through that. And it's really useful because all of this information is being tracked, and blockchain explorers do that. And a term that Kent mentioned previously, cryptography, all of this is happening with math behind the scenes, computer codes, things that are happening that for someone that isn't an expert in programming languages, you don't need to understand that. There are plenty of people that are doing that. What you need to understand is that you can use the Ethereum network to broadcast to send a transaction that's then broadcasted. It's added to this chain through data on a block, which Kent said happens about every 12 seconds. And then that information becomes immutable or unchangeable and can be looked at by anyone else who is interested in doing so. And then all of this happens on the Ethereum network.
Yeah,
I think that's a really important concept of decentralization, which is essentially, if you send, using Ken's example of Venmo, if you send it during using Venmo, you're trusting that Venmo has the state correct. But with blockchain explorers and there are multiple blockchain explorers as well. So if you didn't trust this blockchain explorer, you can just verify on a different blockchain explorer, because what they're doing is they're viewing the Ethereum state. If you don't even trust blockchain explorers because they're too centralized or they're run by companies, if you ran your own Ethereum node, you could use your node to get the view of the transaction as well. So the idea basically being that you don't have to trust anyone that this transaction has been successful, because this transaction is on the Ethereum network, and there are many different ways to consume that information to confirm that the transfer has been legitimately made.
Yeah, and all these terms that we've discussed, like gas fees, GWEI, ERC20 tokens, even though they may seem technical, they're terms that you'll see if you're interacting with the blockchain in any way through cryptocurrencies, dApps, things like that. But all of these also just play a crucial role in making Ethereum what it is as a decentralized world computer, as we're calling it. So these components are what really ensures the security, transparency, and efficiency in the system to make sure no entity has single control. So this is what allows us to have a vast system of decentralized applications, assets, things like that, that we ourselves can build on the network as well as use.
Yeah, and one term that was brought up a moment ago is nodes. And when we say nodes, we mean there are all of these different computers, basically, these different points of access around the world. And these are all being used on this worldwide computer. And they're the kind of the touch points that we talk about. And what Dustin was saying about nodes is you can run your own node, meaning you don't have to use Etherscan or blockchain.com to check out what's happening. You can actually review the data on your own to make sure that it is accurate. But for those that are less technical, you can use this other trusted resource that many other people use and are then comparing to what they see on the back end using their own node. Any other terms that you feel like we should cover before we say goodbye? I know we are at time, but anything else anyone wanted to add before we say goodbye today?
A good
I
one to
feel
wrap
like we
up
need to-
on.
I was
Go
going
ahead.
to quickly discuss proto-dank sharding.
So we're
Me
laughing
too.
because that's one of the terms that is so confusing and we have to start from the basics to get there. And so this is a
Okay, go
really good
ahead.
screen. Josh, stop it.
Sorry, go ahead, Total.
I was thinking maybe we could wrap up on discussing the public good aspect or open source aspect, just to bring it full circle, if anyone wants to jump in there.
That's a good idea. Kent, do you want to bring us back to kind of, you started this, maybe you can circle us back in to see the full picture?
Oh yeah, and sorry, we're going to talk about just sort of wrapping it up, right? What was that, Sonal, in terms of like the exact kind of
Yeah, like how Ethereum is an open source public good.
Okay, so yeah, this is like an incredibly important aspect of Ethereum, and really, as with pretty much all crypto these days, it really lives and breathes on open source. I'm really glad you mentioned this because like this is also a really big differentiator versus centralized, technology that we all have known and used, whether it's banks or Web 1.0 back in the day. Well, actually, maybe not so much 1.0, but like centralized Web 2.0, Facebook, Lyft, any app you use, any website, really, social network. Open source means that anybody can examine the code that's driving these different decentralized applications. So this actually leads to what happens to be one of my favorite aspects of blockchain technology is the inherent transparency. So you can jump into any of these wallets, and they usually have connections with a DEX or decentralized exchange. And you might think, well, how can why would I want to trust some random or some code that exists on the blockchain? How do I know it's actually, if I want to swap my ETH for for another, or for like an ERC20 or something, or make an exchange, how do I know that's going to happen? So this comes back to the open source aspect where you can any code that's published on the chain, and I mean literally any code. There's nothing that's obfuscated or hidden. You can look at it, and of course, you yourself might not have the specialization to know what's going on, but there are certainly people that can audit this code. You can see what's going to happen. So another example is I used to work for a DAO called Shapeshift. At Shapeshift, we had a treasury of assets, and at any given moment, I could point to the smart contract address or the ETH address that held our funds, and I could say, well, we have this and this and this in terms of our treasury, this much ETH, this much stable coins, and you didn't have to trust me. Maybe you think I'm cool, you know me, oh, you can trust Kent, but you should never have to trust anybody in Ethereum. You can look and you can verify on the blockchain that this is there. Open source is also important from the standpoint of just the spirit of building and sharing technology. Things are not a siloed wall in Ethereum. We're not building in a silo. When people come up with new primitives or new codes or ERCs or EIPs, these things are made public. People can then build on them, and it's such a nice paradigm or game-changing shift compared to the old centralized way of doing things, where everything happens in a silo and everything is like very hyper competitive, and everything is like very zero sum. It's like, okay, that works to some extent, but what gets me excited is like people building together and collaborating in a way that really seems to pay off. And ETH has been live since 2015. The ecosystem is massive. So, you know, in hindsight, you'd have to say that things have certainly worked out so far.
Yeah, and I think some of what Dustin's been showing on the screen is just like how much information, how like large this stretches. If you've been reading it, you're probably seeing a lot of words that you may not understand. The point is that we can, you know, shrink this down to some of the basics, and then you can just keep on going. There's so much to learn about this. And so hopefully this introduction got you excited about some of these terms, and you're aware that there's tons of other information out there. So take it slow, step by step, learn more about different things. We hope that at C4 we can be a big part of that. And I think we'll see if we need to do a follow-up on more Ethereum terms. But I think this was a good start. So thank you all for being a part of this live stream, and I really appreciate it. And thank you guys for joining, and thank you for watching. And until next time, have a good time. Enjoy Ethereum. Thank you.
Thank you.
Bye.